Hunt Valley Marathon takes place every autumn and there's many inclines and declines. The diagram shows the cross-section of one part of the run. Determine the length of the run in this cross-section. So, you know, they're running here up a hill, aren't they? Okay, and we want the length of that run there. So it's a right angle triangle. We know two sides. Third side we can work out, of course, using Pythagoras. Okay, so that's going to be my C, always the longer side, opposite the right angle. And then my A and B are here. It doesn't matter which order you put them in. So you've got A, which is 500, square it. B, which is 200, and then we'll square that. Okay, so we type that into my calculator. Okay, we'll literally type all of that in, that calculation there that we see, and that comes to, we've got 2, 9 and 4 zeros, 290,000. So that means then, of course, to get C then, you've got to take the square over and square root that. Okay, 538.5 meters. Okay, so that's the length of the run there, 538.5 meters. Part 2 then says calculate the angle of elevation of the road. So we want this angle here, maybe we'll call it X, yeah? How the road is elevated up, okay? And we'll use trigonometry here, yeah, to work out the angle. So remember Sohcahtoa. Okay, now you know, you're going to need two sides to use. I would use the two sides that they've given me in the question. Okay, I wouldn't use that side because you never know, you might have got that wrong. Okay, you might have made a mistake. So let's use the two sides given, and it's going to be cluttered there. So maybe I'll just draw this out again, right, just so we can label the sides properly for Sohcahtoa. Okay. So we've got 500 this side and we've got 200 that side. That's what I'm interested in, an angle X there. So, you know, that's your hypotenuse, isn't it? Opposite the right angle. There's your opposite there, opposite the angle, and your adjacent there. And the two sides we're going to use, of course, are O and A, right? O and A, so that's going to be tan, isn't it? Toa, so that'll be tan, right? So tan, the angle X will be O, which is 200, divided by A, which is 500. Okay, so you know that's the angle I want, or angle X. So I'm going to take the tan over. So remember, tan to the -1 on your calculator. Okay, and then 200 over 500. Okay, so you can type that in one go. If we press a shift tan and then fraction 200 over 500. Okay, and then you get your angle out, 21.8 degrees. Okay, part B, it says the diagram shows another cross-section of the run. During this cross-section, Rowena runs 600 meters. Calculate the horizontal distance covered. So basically, it tells us there, right? She runs 600 meters, so up there, okay? So we want the horizontal distance covered. We want this side here, yeah, that's the horizontal, isn't it? Going across. So again, using trigonometry, hypotenuse here, yeah? Longer side, opposite the right angle. Opposite here, the angle, and the adjacent here. So using Sohcahtoa, right? Well, you know, if I want the horizontal distance, I want A, don't I? I want A. I've got H. So basically, in this case then, it'll be those two sides, so A and H, which is car. Okay? So cos 32 equals car A over H. Okay? So it'll be A over H, which is 600. And then to get A, I just got to take the 600 over and multiply. Okay, let's get my calculator. 600 times cos 32, and that will come out to be then 508.8 meters. Okay, and we've got our horizontal distance. Similar situation then to work out the vertical. So again, maybe I'll write out Sohcahtoa again, but this time now, notice, I want the vertical, so I want the O, don't I? I want the O, and I'm going to use H. So O and H I'll use. So that'll be sine. Okay, so sine 32 equals O over H, which is 600. So this time now I take the 600 up, and I get 600 times sine 32 and that comes out to be 317.95. Okay, so if I wanted that to be one decimal place, that would be 318 then, 0.0, isn't it? Okay, meters. Okay, part C then says the final part of the run is a downhill sprint to the finish line. The road is quite uneven. The vertical distance in this section of the road is 250 metres, and the angle of depression is 15 degrees. Calculate an estimate for the distance that Rowena runs during this final session. So we want this length here, yeah? And the angle of depression, or the angle of depression, you go down, right? If you think about depression, it goes down. So we want 15 degrees. That will be the angle of depression there. You're looking down from the hill. Okay, 15 degrees there. Okay. The other way then of thinking about it, well, if that's 15 degrees there, looking down, well, you can work out what this angle is, couldn't you? Okay. Or you could appreciate then that this is also 15 degrees here, because you've got a Z angle. Okay. So 15 degrees, same as that angle there. The other option is you could work out this angle, because that's a right angle, 90 degrees. Take 15 degrees away from 90, you get 75. Okay, so there's two ways of doing it. So opposite here, opposite the angle, hypotenuse here, and adjacent there. So I'm going to do I'm going to use O and I'm going to use H. Okay, so that's going to be Sohcahtoa. And of course then, if it's O and H, I'm going to use sine, right? So it'll be sine 15 equals to O, which is 250 over H. Now remember, we've had the situation in the previous question where the term is on the bottom that we want. So you've got to take that term up, because you're dividing by it, take it up and multiply. And then to get the H on its own, you've got to get rid of that sine 15. So you appreciate then we'll take the sine 15 over, because we multiply, and when you take it over, you're going to be dividing. Okay, so 250 divide by sine 15, and that comes out to be 965.9 meters. Okay, and it says state any assumptions you've made. Okay, well, what we've done, we've assumed this is flat, isn't it? Okay. We've assumed it's flat. It isn't flat, but it's close to being flat, isn't it? So we assume the road is flat, and we have to do that in order to use trigonometry. Because if you think about it, trigonometry is to do with a triangle. Okay, triangle. If that's not flat, it's not really a triangle, isn't it? There's a bumpy road there, so it's not really a triangle. But because it's quite close to being flat, that's what we assume. We're assuming the road is flat. What is the impact of the assumption on your answer? Well, basically, the road isn't actually flat, isn't it? Okay, so even though we've got this answer out here, likelihood is he's probably run a little bit further than this. That road there is probably a bit more than this, isn't it, if you think about it, because it's bumpy, you end up going down a little bit, up a little bit, down a little bit, up a little bit, and so on, right? So then that adds to your distance. So the likely run distance is greater, okay, due to all of the peaks and troughs in the uneven road surface. Okay, so it's going to be slightly greater. It won't be that much greater, but it probably will be greater.